right? So this one's all about a review of different trig functions, radians, types of angle measurements. So one thing that hasn't come up in the exam so far, but could, the idea of coterminal angles was like the first thing we talked about when we started thinking about like what a rotation was. And if you guys have a positive degree measurement, we went up that amount. Then if it was negative, you guys had to go down. But the idea behind coterminal angles is that they would end in the same spot, okay? So coterminal angles end in the same place. Right. So what you guys want to think about to kind of help you is look at this completed coterminal angle. What does it look like? A circle. So coterminal angles, to kind of be safe, they usually will create 360 degrees because they kind of end at the same spot and they make a circle. The idea behind them, you have to be careful though, is this one's going up, so it's positive, but the other one would be negative. So why don't you guys think about what would be coterminal with 125? If you need to draw it out, so 125. How does that feel? The end is the same spot. You want to figure out what this green line has to be. Negative 235? Yeah, that's good. Good job. So it's down, negative, and if you guys took 125 plus 235, oops, 235, you would get 360. Good. Thanks first. Perfect. Again, that's not a huge topic. You know, you might get a question here or there. So what is the big topic, and you guys have already kind of seen this show up in the Regents we worked on, is the idea between converting from degrees to radians and radians to degrees. And you've done a good job memorizing like your conversions, so you know those really good. So if we have 45 degrees and we want to go into radians, I think to remember the pi is on top in the radians, right? Because most radians have a pi in it, so it goes on top. Why don't you guys do your conversion? See if you guys can do this one. Let's go. Thank you. So when you do your multiplication, you always want to leave these in simplest form. So it's where your calculator comes in handy. So we're going to take 45 divided by 180. And then do your math fraction key. So this is going to be like pi over 4, or 1 pi over 4. How was that one, Susan? Easy? All right. Now this one, again, not too bad. All right, pretty easy. So if you're going from radians now into degrees, right, the pi's got to be on the bottom, so it would be able to cancel out with the other one. So times 80 over pi. Okay, so when you multiply by this one, pi's will go away. 5 times 180. And then we're going to divide that by 12. 75. Good? Right. So those are like, you know, if they want to be nice, they'll give you guys something like that. Not too bad. But unfortunately, I have not seen them be nice. And they like to do kind of what we went over today with number like 29, where you have to use some extra stuff. This one would be a tougher one. So stuff like this is pretty big now. Convert 3 radians to degrees. Then express it to the nearest minute. I remember, but I don't know how to do it. Okay, so this is good at going over it. So the first thing is they want you to convert radians to degrees, right? So let's go through and kind of do our conversions. We have 3 radians, and if you want to go into degrees, what do we have to multiply by? Good, thanks, Bill. 180 over 5. Now this is kind of special, like the one we did today, right? You don't have a pi to cancel it out with. So when we enter this in our calculator, that pi is the actual pi key in the calculator. So we're going to take 3 times 180 over Did you guys get 171.88?
Yeah.
Okay, so now this is in degrees. If you guys want to go into degrees per minute per second, what we need to do is use this key. Second app, that means to make this go into degrees per minute per second. So go to your second app, right? Go down to choice 4, where it says DMS, and then hit enter. So now it changed it into degrees per minute per second. And we wanted to watch a couple things with rounding. This is your degree part. This is your minute part. When you guys went to round, this is your seconds. So think about, it's a little bit weird with rounding. There's 30 seconds in a minute. So if this was like 30 or more, we would go up. If it's less than 30, we keep it the same. So this would be like 171 degrees and 53 minutes. Yep.
So say that was like 32 seconds, then maybe 54.
Exactly. Yep. If this was, it could have been, just anything over 30. If this was like, 38, whatever, right? This would go up to 54. How is that? Yeah. When they say to the nearest minute, they're assuming it's like the whole thing, but to the minute part. Like how it says if they say something to the nearest tenth, you just you don't ignore everything else that's in front of you. Just go kind of see right there. So one. Oh, there's 171. 171. Great. And then now this one again would be a nice easy question, but they're things if you guys don't practice them, you don't remember it on the calculator, you can't really do it. So just find the value. So typing those special second app keys in.
Yeah, we don't have that on.
Oh, you don't have this one here?
No.
Oh, curses.
It goes to the next example.
All right. Do you want to do this one? Can we do it anyway?
Yeah.
When I move these, like when I cut and paste everything and shift them up or down, like some of it's covered. I didn't realize. Sorry. All right. Okay, so sine 87. Make sure we are in degree mode too, especially if anybody was working with the trig graph at all. Just make sure you're in degree mode.
I have a question. We were doing I was starting the multiple choice in class. How do you know the difference between the trig graph and the regular graph? Like if you're seeing a picture of it.
Oh, okay. Well, usually trig graphs look like waves.
So it'll be dealing with sine and cosine.
Yeah, it might be like a secant or a cosecant, and those are views.
Yeah.
It'll look like something weird.
It won't just be like a curve.
Like a line.
Right.
Right, yeah. It'll, usually you can tell by the multiple choice too if you see a bunch of
cosine,
sine, secant, that kind of stuff. You don't have a lot of plane graphing function on your test. So it's usually more like those. Okay, let's do sine, and then to get your stuff, so we're doing 37 degrees, 37, right, same key, second app, put your degree sign in, and then 34 minutes, so 34, second app again, 2, close it, there we go. So they wanted it to the nearest 10,000 spot, I think it was. 10,000, so this would be a 7, yep, 6097. You guys remember the keys now?
Yeah.
Kind of fresh with them? Right. There'll be one question usually per exam. I think it showed up actually in the front list and noted, but usually they have somewhere in the problem where they like this type of conversion. I mean, it could show up in a bunch of different spots, but they like those. All right. Okay. Theta equals S over R is the arc length formula. Was this on something in the multiple choice maybe for the last test? Anything with S over R?
I don't think we have one.
No, not yet. Just a couple things about when you use it, some of the keywords you guys are going to see. Whenever you're talking about a central angle and you have a radius or an arc of a certain amount, that's kind of your clue to use theta equals S over R. The theta, though, is always central angle, and a big thing, it has to be in radians. So if it's not in radians, we need to do the conversion and make it into radians. The S is always the arc, and R is the radius. So when we read our first one here, in a circle, we got an arc length of 5. It's intended by a central angle. All that means intended is that it's cut. So it's backed by a central angle. 5/3 radius. What is the radius of the circle? All right, so always just kind of fill in our information. Make sure you're reading carefully because a lot of people confuse radius and radians when they read. So just make sure you're careful when they're picking. What's your central angle? What's your data going to be? Good. And see how it already says radians? So we're good. It's already in the right part. The arc, the S, radius, 5, good. Radius is, you don't know. Yeah, do the R, you put an X there, whatever you want. All right. So theta equals S over R. So theta equals S over R. We're going to put in 5/3 for that theta. The S is 5. You don't know what the R is. When you guys have two fractions with an equal sign, what is good? Have to multiply those. Awesome. So we have 15 equals 3R. Divide by 3. So R is going to be, oh, what did I mess up here? Oh, it is 5R.
Yeah.
Oh, thank you. That'd be 5. 5R equals 15. 5. Good. So R is 3. Nice job. Pretty easy. Right. So you guys can kind of see there's a variety of ways they can kind of ask you guys things in different caliber of questions. That'd be an easy example. If they wanted to be pretty neat, okay, here's an example that's a little trickier. 2.40, yeah. Oh man, all right. So this is pretty tough. Do you guys know the difference between a minor arc and major arc? You know that from geometry? Minor is like the small, major is big. Makes sense, you know, right? So the smaller part is this one. Right, so here's the minor arc, right? That's what we're looking for. So in this problem, we got an arc. We do have a central angle of 165 degrees. We do have a radius. So we're going to use theta equals S over R, but we have some issues. Go ahead, love. Yes. Okay, you can't work with this when it's in degree form. So we need to take 165. How are we going to convert that to radians? Perfect. Pi over 180. Awesome. Okay. So let's do that conversion. So 165. Did you guys get 11 pi over 12? Yeah. Okay, great. Okay, good. All right, so my theta is 11 pi over 12. There we go. Now what's the arc? What's the S?
The length.
The length. Do we know what it is? No. This is your arc. That's your S. Do you know what the AB is? No, so that's going to stay S. And the radius is 2.4. So we're going to cross multiply. Now, when you guys do 2.4 times 11 pi, use the key in the calculator. Like actually use the pi key. Yep. Especially because it says 0.1 of a meter, so we're going to have a pi left.
How would we check this one?
2.40. So 2.40 times 11 pi. Right, so we get that decimal, 2.93. That's going to equal 12f. Okay, so then we're going to have to divide by 12 to get f along. Take this, we'll divide it by 12. Did you get 6.9? I think it says nearest 10, so just be really careful. Okay, so yeah, nearest 10, so it would be 6.9 would be the arc. Like that. See the difference in difficulty level?
This is probably like a stupid question.
No.
Say it was 6.99, and then you just write 7.0.
Yeah, 7.0.
Okay.
Good job. And you know, usually they won't do that just because it's like, because you could have done to be a whole number.
Right.
So you know, they try to be like a little bit trickier. Okay. This isn't really, I guess, like questions, but let's just make sure we remember your unit circle, where things are positive, where they're negative. We've done this a lot recently, so hopefully it's kind of fresh in your head. The ASTC, you guys could have like all students take calculus, all scientists take chemistry.
Other way is ask.
Have you
ever noticed that? Like if you go
clockwise?
No, like ask.
Oh,
A-C-T.
No, A-C-T-S. No, other way. Ask. Like an act?
Like an act.
Ah, act. All right, I like it. Yeah, there's like a ton of ways to remember. So.
All strippers pay cash.
Perfect.
That's how I remember it.
Perfect. Good to know. Okay. So whatever way you like, I don't care how you memorize it, just make sure we know where things are positive. And this is talking about where they're positive. So in the first quadrant, all of them are positive. The sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. All 6 are positive there. What about in quadrant 2? What's positive? Sine, good. And what's sine's reciprocal function? Cosecant. Great. So those 2 are positive in the second quadrant. What about tan? Oh, shoot, sorry. Tan, and then what other one? Cotangent, good. And then cosecant. Good. Yeah. Perfect. Good job. All right. So that's just where it's positive. We know our quadrants 1, 2, 3, 4, right? And when you guys are looking at your ordered pairs, think about the unit circle has a radius of 1, so you need to get over here, you're moving like 1 unit, then you're not going up or down, so that's like 1, 0. Do you remember which one's the cosine, which one's the sine? Good, C comes square. Good job. Yep, so it's always cosine first, then the sine. Here's your ordered pairs. Okay, we haven't done these in a while. I'm going to give you guys like a little sheet, maybe Monday, of just like, all right, fill your ordered pairs real quick. You know, a little bit of practice. So, the way you remember those, the 30-degree ordered pair, the radical 3 had to come first, then over 2. And then if you knew this one, you could get to 60 by just flipping. Right, flip to get to 60. The 45 is radical 2 over 2, radical 2 are the same. Do you remember those? Oh yeah, you got to 60. Yeah. Okay. All right. So again, reference angles, I feel like we've been using these all the time. A lot of this trig stuff is pretty like recent. So the reference angle is always acute, meaning that it's less than 90. And I kind of showed you guys when you make your reference angles on your axis, they want to look like a bow tie. So when you guys look at the reference angle in quadrant 1, okay, it's kind of its own angle. But in quadrant 2, it's 180 minus the angle. Right, in quadrant 3, to get down here, it's 180. Good, that's the angle. Great. Yeah, that's the angle. What about if you guys were to try in quadrant 4? Subtract, yeah, good. 360 minus the angle. Good job. Right. Just make sure if you're going down, right, you're subtracting, going up, like in number-wise, number values. So like you're going 360 and you're going back, this is like 270, so you have to go down subtraction-wise. But if you're going from 180 and you're going this way, so 270 to add, it's getting bigger. And we're kind of having issues with like when to subtract, when to add. Just make sure you're always using the x-axis. Nothing with 90 and 270. It's always 180 or 360 that you're going with. All right. We had a question kind of like this, Shoal, and I know it confuses with what like the angle is talking about. So see if you guys can figure out. Right? They're giving you x and y are the ordered pair. They want to know if this angle is 150. What does the x have to be? Okay? Think about like this as cos, then sine. Like the x is the cosine, the y is the sine. Anybody know what the reference angle is in here? 30. Good job. Nice. Right. So from here, here's 150. Right. This is 180. There's 30 degrees as the reference angle. Now, in your reference angle, we also need to think about what quadrant you're in. You're in the S quadrant. So if we are looking for the cosine, is it positive or negative? What's negative? And the negative cosine of 30, what would that really be? Good job, Will. Negative radical 3 over 2. And this cos 30, this is why you guys really want to know the ordered pairs, right? So when you look at the ordered pairs, the cosine is the first one. So in here, you want to make sure you know that the cosine of 30 degrees is radical 3 over 2. Right. This was just like one I thought that was kind of, the next two are kind of just like more exact value things. But if you see anything in radians like this, don't work with them. Change it to what you guys know. Make it into degrees first. Yep. So times this by 180 over pi. What would your actual degree measure be? Alright, so 240 degrees, we can't just take the sine of that. We probably want to do a little bit of work. So if you make your little chart and think 240 degrees, somewhere in here. Okay, here's your 180. What's the reference angle? Did you make it? 60, good job. 60 degrees, nice. So I'm going to be dealing with the sine of really 60. Again, don't forget about your quadrants though. What do we know about sine in the T quadrant? Negative. Good. All right. So order pair at 60 degrees. Which one's the sine? Negative radical 3 over 2. Good work. Nice. So if you guys have kind of forgot about the order pairs, right? Make sure you know because calculators can't handle radicals. So it's crazy stuff. All right. We've seen a couple things, I feel like, with exact values show up. Stuff that kind of looks like this where you're adding and multiplying. So let's convert these first, and then we can figure them out. Good, 30, nice. We're really taking the sine of 30 plus the tangent of 45. Very nice. Okay, good. So use your order pairs for some help. Anybody know the sine of 30? It should be 1 half. Good job. Now tangent of 45, tangent's a little bit tough because you have to do the sine over the cosine. But when we had 45 degrees, this was nice. Do you guys remember what they were? Radical 2 over 2 divided by itself, which is just 1. So the tan of 45 is just 1. Yeah, you could actually, because there's no radicals that came up. But if there were radicals, you have to do it on the paper. So you kind of left down here. So 1 plus half is radical 3 over 2. Good. Oh, that's okay. Alright, and I mean, if you guys get one like this, super easy, you gotta get them right. Just talking about where we're positive and negative. So just look to see, there's going to be 2 clues in here. If your sign is a negative number, that means that this is negative. If the cosine is bigger than 0, what does that mean? Positive. Good job. Perfect. So really, when you guys are doing your ASCC, okay, which one does it have to be? And if cos is positive, but the other thing? 4. Good job. Got it in here. Thanks.
It can't be an A because even though cosine is positive, the other one would have to be positive too. Great job. Alright, those are nice little teeny ones. You needed to. Good so far?
Yeah.
I feel like, are you guys remembering most of this?
Yeah.
Like I feel like we kind of do this a lot, but. Alright, reciprocal trig functions. Just a little quick, kind of go over these. So if you are having trouble memorizing them, the secant goes with the cosine, right? C's and S's go together, so the cosecant is really the sine reciprocal. Yeah. Cotan's a little bit tricky. I remember co and then co, so that kind of helps you with the order. Basically, the reason, like, for reciprocal functions, you guys can see them, like, come up two ways. One way is when they want you to do some kind of, like, reducing, something like this. We always want to turn things into terms of sines and cosines, so more things will cancel out. So if they have you guys simplifying or doing any kind of operation work, rewrite it first. So we're going to turn secant into 1 over cos. Yep. What's cosecant? Awesome. Okay. So just because you have trig functions, don't panic. We're still going to multiply by the reciprocal or copy, change, flip. So we copy, change division to multiplication, and flip the second fraction. Okay, so now we have, oh, those are so good, sine over cosine, but that's not one of our answers. What does that equal? Tangent. Good job. This is the same thing as tangent. It works. They like to do that where they won't give you the answer, you have to know what it is. That's like a trig function. This one's easy. It's a little bit kind of different. There's almost like no work involved in it. Right? It's more work, more looking at the relationship. Anyone have an idea what you think it might be?
What does it even have a line?
Oh, okay. It just means that A can't be equal to 0 because if you put 0 down here, what would that become if you have a 0? Undefined. So it's just saying that A can't be 0. That really serves no purpose except to just like be mathematically correct that it can't happen with 0. Yeah, thanks, yeah, perfect. That's exactly it. Right. The relationship between cosecant and sine is that they are reciprocal functions. They go together. So if you know one of them, to get the other, all you do is flip the fraction. So it's like A over 1, which is just A. Good job. Right. This could be a tougher one. Right. Express the exact value of cosecant 60.
So when they talk about exact value, don't they want like
Yeah, the radicals are good. I love that, Ashley. Nice. Because this has come up quite a bit, right? Exact value usually do something with order pairs. Meaning like you can't just type this thing into a calculator. So you have to know what cosecant goes with. Anybody know? 1 over the sine. Good, okay. So this is the thing, 1 over the sine of 60. Right? So what is the sine of 60? Good, yeah, radical 3 over 2. Good job. Right, there's your order here. Here's your sine. Good. So we have 1 over radical 3 over 2. What do you have? Well, copy, change, flip. Yeah, you're right, Kim. We can't really do this. So you have to simplify it, and you can't write it on the bottom. So if we copy, change, flip this thing, and this one's gone. So now we have 1 times 2 is 2 over radical 3. Can you leave it like that? So what do you multiply by? Good job. Radical 3 to rationalize. Good work. So 2 times radical 3 is 2 radical 3. On the bottom, what happens with it? Perfect. Nice. Well, good job.
How do you know when to multiply them? Like for it to be 9?
9.
You know when they're both in the...
Oh, like in here?
When they're not right.
Yeah, or like if they aren't the same, like if one, I mean, it wouldn't be with rationalizing, it'd be like if I gave you like 1 over radical 5 times 1 over radical 3, you know, something like that. You could do like 1 over radical 15, but then you would still want to multiply by radical 15.
Okay.
You still want to get rid of it. Most of your rationalizing is going to come up though with like stuff like this. Okay, or if you just had to use like a conjugate or something. Oh, we had one of these the other day. Right? Talking about like arc. It's arc. You guys can see that also. It's like the inverse. They may have also done cos -1 instead of the arc cos. Those mean the same thing, right? So both ways will work. If you ever have like a function on the inside and one on the outside that you have to do parentheses first. Do your PEMDAS and then take care of what's on the outside. So arc cos of 5/7. Okay, we want to do second cos of 5/7. So now you want to take the secant, though, of this. So, do we have a secant button? No. How would we put that in? 1 divided by cosine. 1 divided by cosine. Perfect. Right? And use that second answer key, right? Especially when you're dealing with these decimals that this isn't our answer, we're kind of using it. So put it in so it doesn't round anything. Right? And we get 1.4, which is 7/5. Alright, well, it doesn't really matter, it doesn't say which way to leave it, but Dina's fine.
So if it's like that where it's the opposite on the outside, you flip the fraction.
Yeah, that's the same one. Remember the one we did?
Inside.
In class was like that.
Yeah.
And the same one is like the inverse of each other. Yeah.
How did it come to that?
Okay, so do arc, so that's okay. So arc cos. So like see the inside part. You guys go to the next one. See if you can do the next one. Right. So arc cos is 5/7. So arc cos and second cos. And take the 5/7. Now this, all this is what arc cosine means. Of course, you still secant of this, but you don't have a secant button now. That means you're secant. You're welcome.
Then you guys did your arc sine of radical 3/2. What did you get for that part? 60? Good, okay. So now if you take the cos of 60, yeah, good job. Good for all of these? Okay, I just want to go quick over the identities. Well, I know it's a little longer, sorry. This actually came up in the Regents we were doing today. And you know the very most important first Pythagorean identity, you can get the other two by deriving. And what I mean by deriving is imagine if you took your original and you divided them by sine squared. You divide each one of these by sine squared. What would you get if you did sine squared divided by sine squared? 1, good. Plus, good job. Awesome. And just make sure you guys keep your squares on there. If these are squared, your reciprocal functions are squared too. So good. So this is the second identity. Okay. Now, if you want to get, let me see some room here. If you want to get the other one, and what do you divide by? Cosine. Good. Nice job. So if I took all these down, divide by cosine squared. Okay. So sine over cosine squared is going to be 9 plus good. Yes, good job. Great. Okay. So that was just one way that you guys could get the other two without memorizing. Right? If you know the first one, which you're really good at, to get the other two. I don't think the other two come in to like say a lot of times the problem is that one does it. Like that one time. Okay, so if you have something like this, let's see if you can simplify. Well, yeah, thanks for good job. Still have two terms, that's two terms. So 1. Watch your signs. Negative cos times positive cos. So negative cosine. Perfect. Good. Right. What's going to happen in the middle? Anything? Great. So we have 1 minus cosine squared. But look at, well, this will come up quite a bit. When you have 1 being added or subtracted to a trig function squared, usually it has something to do with your identity. So if you guys imagine 1 minus cosine squared, what is that the same thing as? Yeah, it's using this one. And what is it doing? Good job. Yep, sine squared theta. Good job. Because we imagine if you subtracted cosine squared over here, you're left with sine squared. So this really is sine squared theta. Because they want you to write it in terms of sine. That's kind of like your clue that you needed to write this over with the sine. They would like to do this as a multiple choice and not have 1 minus cosine squared as an option. So it's kind of like needs to go the other way. Alright, last little part is quick. I've seen it come up, I think, twice ever on exam. And they're called co-functions. You guys like them. Co-functions, they kind of sound like they go together. Sine and cosine are co-functions. Cosecant, secant, co-functions, and then cotan, tan are co-functions. The idea behind co-functions is that if these two trig functions are equal, that means that the angles must add to 90 degrees. Think like co-functions are complementary. Like complementary means they have to add to 90 different angles back in the day. So if you guys notice that you have two functions that are co-functions, tan and cotan, they're saying that these two things are equal. The two trig functions are equal. What would you know about their angles? They have to add to 90. Good. So if we take the two angles, x plus 20 plus x, it has to equal 90. So they want us to find x here. So I will terms.
Wait, did we do?
Yeah, we did this. It like doesn't show up like ever. Yeah. So it's good that we're going over. I mean, it could be one. Would you see this? Would I get money about it? Probably not. But
so like that's you set them equal. Is it sine cosine
yep. Yep. Their angles add to 90. So then you would get x equals 35.
Would they ever do? I know you said that these aren't really options, but would they ever do like I don't know what to ask, but like one of them over one, so then it would be a different co-function.
No.
Okay.
No,
Do you understand what I'm saying?
yeah, yeah. No, I haven't seen anything like that.
Okay.
I mean, it's something that's been come up. These are nice because they're multiple choice.
Mm-hmm.
If you really couldn't remember what to do, you could take this and plug it in, you know, for every value of x, and then use your calculator to see which ones will make it equal.
Yeah.
You know, when I did it was a part 2 though, so you could do that. So, but if it's part 1, at least you luck out there. When you guys added these and you set them equal to 90, what'd you get? You got 12? Nice as well? Yeah. Good. Good job. How is this one?
Was this the unit where when we had the radians that like
Oh, I think that's something else. I think you're thinking of completing a square with like trig. Or not with trig, sorry. Completing a square with like x's and y's.
Oh,
maybe?
Yeah.
The other way, like on the top of the co-function sheet that I gave you guys, is stuff like this, like sine A equals the cosine of 90 minus A. And I know you guys didn't like the way it looked. Because if you think about this, if you add these, what would they still be? 90. So like if you add A and a negative A, it'd be cancel, you would just get 90. They're saying that the two things would still add to be 90. This is a tougher way to see it. So, guys,